right, 4.1 is today. It is tomorrow. It is Tuesday. Tomorrow meaning Monday. But actually Monday we're doing a world famous Winkler activity.
You gotta get all the angles in there.
Wait, does that mean we're going to AW?
Yes, that'd be so cool. I love AW.
Then 4.2, just ignore you. So 4.1 is actually due the Monday after break. Then 4.2 stuff, and then you've got a quiz on 4.1, 4.2 the Wednesday after break. Then a quiz the Friday after break on 4.3. Then 4.4. Spend a few days on that. What have you heard about Chapter 4?
It's awful.
It's extreme, yeah. 4.4 is extreme, yeah.
The hard
But yeah.
section.
It's probably the...
Toughest part of the year.
Yeah, it could be. Like the first half of Chapter 4 is like really gnarly derivatives where you can do like 10 steps and you mess up on one little spot and you get the whole problem wrong. And then the second half of Chapter 4 is real life applications that require a lot of thinking and all story problems.
We had one of those last year at the end of the year too. I remember our quiz was just like one big problem.
But this is the last chapter on derivatives. Once we make it through Chapter 4, you're technically through kind of Calc 1, where the whole Calc 1 is derivatives, and then the second semester, or the second half of Calc, is the opposite of derivative, which is an integral or an antiderivative. We'll start doing that in Chapter 5.
So it's still there.
So you need to know derivatives in order to do the opposite of a derivative.
It shows the
Okay, is this class still an AP class? Did you like hear from that? Those people?
I called, and I was on hold for 20 minutes, and then the bell rang, and I had to stop being on hold. So I have not made any progress. But I have a little post-it to call again on my desk.
Thank you.
Either way, you can take the AP exam.
What if it changed then for you?
They might not be able, they won't let me call it AP calculus.
But it's
Wait,
still
so would it
working.
just be CITS calculus?
Yeah.
It will not be CITS anymore after this year.
It'll just be calculus AB.
Yeah, because there's not going to be any more CITS math classes after
Right.
this year, right?
Wait, next year the Calc BC though is CITS, right?
No,
But it's AP, so it doesn't matter.
Yeah,
Uh,
so you can still get college credit.
BC has never been a CITS class.
Okay, so today we're doing 4-1. We get back from next week. We have just the 3 days.
Scenery
And then after break,
shots.
we've got the 4-1-2 and the 4-1-4-2 quiz on Wednesday and the quiz on Friday.
You get all that?
Not really. That's what I got.
Right. Okay, so 4.1 is extreme values of functions. So we've talked about this a little bit. So I'll just do, let's say this is negative 2x and this is x plus 10 or something. And I want to find the maximum area of that rectangle. So my area equation is negative 2x times x plus 10. So negative 2x squared minus 20x. We could use calculus to find out, do a derivative. We get negative 4x minus 20. And you could, well, if it's a parabola, it opens down. The maximum area would be right at the peak or the vertex. So you could set that equal to 0 and pretend like we get a positive number and we get negative 5. Okay, so I guess that's okay that we get a negative number because that's just, it actually produces two sides that are positive, right? Mm-hmm. Negative 5, that gives you 5, and that gives you 10.
That means like the
Okay, so you can plug negative 5 back in to the original, a of negative 5, and I get 10 times 5, which is 50. So the maximum area of this scenario would be 50 units squared.
Alright.
Okay, so that's very fundamental. It's a nice, easy derivative, but the process is you'd want to find where the derivative is 0 because that's where it peaks, and then plug it into the original. Okay, so how do you find extreme values? You find extreme values. Step 1 would be to find derivative and set equal to 0 and solve. That's kind of what we just did. This is not in your notes. You should write this down. Basically, everything you need to know from this section is going to be right here.
What are the notes then?
Hey,
Why are they on graph paper?
Graph paper is the bomb. Talk to Mrs. Connor.
All right.
about my graph paper.
I'm gonna sell this and get the
She
royalties.
writes me cute little notes every time I use it.
another extreme, so they're called extreme values or extrema. Some people call them. I call them extrema. Another time where it could happen is where the bottom of the derivative is 0. So kind of where derivative is undefined. But more specifically, where the bottom equals 0. Okay, so an extreme value could occur there. Another extreme value is at the endpoints. If the domain is restricted. So sometimes they'll say, here's your f of x, and we only want f of x to be from -1 to 3. So you might have a nice cool graph, but then all of a sudden it stops. And it stops on one end, stops on the other end. You could produce a relative min or relative max on either end. Are you familiar with relative, or are they local? I think you, do you remember?
It says local in the textbook, I think.
But does our pre-calc book call them relatives or local? They're interchangeable. Okay, so maybe I should slow down and draw a scenario that will show you all these cases. So I've got this. All right. Call this A, B, C, and D. All right. So when we do number 1 up here, where we find the derivative set equal to 0, that will give you any horizontal tangents. Which of those letters is a horizontal tangent?
B.
That's right. So that's a horizontal tangent. Nowhere else in my function f of x is there a horizontal tangent. Okay? So at B, so that will tell you where there's a horizontal tangent. In this case, this is a max or a min. Do you see that it's a max? And it could be, it's a relative max right there. But even more specific, it's actually the absolute max or extreme max. We'll call it absolute. Okay, because there is no point higher anywhere in the function where it's defined. All right. Where is the derivative undefined that produces a min or a max?
C.
At C. Very good. So that's at C. And that is a min. And they're all relatives. So whether it's a max or a min, all of them are relative mins or all of them are relative max. But some relative mins and relative maxes are actually the absolute min or max. In this case, this is the absolute min. And then the other two are endpoints. There's a min and there's a max. That's not an absolute max, right? Because there are higher points somewhere. These are higher than those, so that would just be a relative max. That's a relative min. Okay, so we find the derivative, set it equal to 0, solve. Now I'll give you critical points. They're called critical points where the derivative is equal to 0. Then you find out where the derivative is undefined, or set the bottom equal to 0. Okay, we need an example. So there's one in your notes. I'm not going to go through all of it up here on the board. Maybe I can. Do you want me to?
Sure.
Might as well. All right. It's not too hard. All right, first thing we want to do is find the derivative. Go figure. So product rule. So I have x to the 2/3 plus 2x plus 2 over 3 cube root of x. So there's my derivative. We set it equal to 0. And solve. Maybe I'll subtract that. And I'm going to multiply by the bottom, so it's now 3, negative 3. X to the 1/3 times x to the 2/3, you add the exponent, so you just get x. So negative 5x equals 4, so x is negative 4/5.
What common number did you multiply by?
Right here?
Yeah.
I multiplied by the denominator both sides.
3 squared x.
3 cube root of x.
Oh, cube. That's a 3. I was.
Yep. Okay. So we have a horizontal tangent at negative 4/5. If you have a horizontal tangent, does that mean you will always have a min or a max?
No.
Yes. It just might not be global. Absolute.
Yeah, so another word is global. Global and absolute are the same thing. They're interchangeable. So if you have where the derivative is 0 or a horizontal tangent, it will always either be a min or a max? The answer is no. You could have something like this. So that horizontal tangent occurs right there, but it's not a min or a max. So it'll flatten out. It's a potential min or a max or extrema, but we don't know for sure if it is one.
It's still a critical point, though, right?
It's not a critical point if it's not a min or a max. So it's a potential critical point, I guess. There's a lot of vocabulary we're throwing around here. So critical points are where your where your derivative is 0. So what x values produce a derivative of 0. It's a potential critical point. Okay, so we got that. Number 1 is done. We've got one potential min or a max. And if I want to know what the y value is, you'd plug that into the original to get the y value. I probably did that in a sheet somewhere. I don't want to do that. Okay, step 2, find where the derivative is undefined. Okay, so this is my derivative right here. Okay, so I do have an x in the bottom, so I could just set that equal to 0. So cube root of x equals 0, cube both sides, so x equals 0. Something happens at 0 also. It might end the graph, there might be an endpoint, or it might be like a cusp,